Good morning everyone. In this video, I'm going to discuss the describing individual performance. So in this video, I'm going to discuss the different kinds of converted scores. The procedures for converting raw scores to standard scores are presented in this video. There are four types of standard scores: the Z-score, T-score, standard score, and percentile ranks. But then, I'm just going to discuss the two ones, the Z and the test score. And then the rest will be discussed by Donna Rose and Arlene. So, scores directly obtained from the test are known as actual scores or raw scores. Such scores cannot be interpreted as whether the sum is low, average, or high. Scores must be converted or transformed so that they become meaningful and allow some kind of interpretations and direct comparisons of two scores. So as you can see in the screen, there are two bell shapes, the figure A and figure B, in which figure A represents the score distribution with a mean of 50, as you can see, the mean of 50 with a standard deviation of 10. So 20, 30, 40, 50, 60, 70, 80. While the figure B represents the score distribution with a mean of 80 and standard deviation of 5. So the bell shape of two score distributions above is the same. However, the means and standard deviations are different. So this happens because the ranges of the scores from figure A differ from figure B. So in this case, the scores in those figures cannot be compared because they belong to different groups. So what is z-score? So the z-score is used to convert a row scores to standard score to determine how far a row score lies from the mean in standard deviation units. So it is also to determine the proportion of the total area greater than, in between, or less than an empirical value. So the z value is positive when the row score is above the mean, while the z is negative when the row score is below the mean. So from this, we can also determine whether an individual student performs well in the examination compared to the performance of the whole class. So, to determine the exact position of each score in the normal distribution, we will use the z-score formula. So, formula of z-score equals to z equals to x minus the mu, or the u, the Greek symbol, all over the sigma, or z equals to x minus the x bar, or the mean, all over the s, where z equals to z value, the x for row score, s sample standard deviation, x bar sample mean, sigma for population standard deviation, and the mu for population mean. So for example, using the data below about Oderbien's score in calculus and trigonometry, solve for the z-score value. So here, we were going to know kung asa mas dako og score si Oderbien sa calculus ba or sa trigonometry by using the z-score formula. So Oderbien's score in calculus of 92 with a mean of 95 and the S, or the standard deviation, of 3. So by using the z-score formula, 92 minus 95, which is the 92, ang score niya, i-minus nato siya sa mean of 95. So mo equal siya og negative 3. I-divide nato siya sa 3, which is the standard deviation. So mo equal siya og negative 1. So then the z for the calculus is negative 1. On the other hand, the trigonometry, in which Audrey-Bien's score of 88 with a standard deviation of 80 and a standard deviation of with a mean of 80 and a standard deviation of 4. So by using the z-score formula, so 88 minus by 80, which is the 88 niya is the score niya. I-minus to siya sa mean, which is the 80, equal siya og 8. I-divide na to siya by 4, it is because sa standard deviation. So 8 divided by 4 equals to 2. So therefore, the score of Audrebian in calculus is 1 unit standard deviation below the mean. Therefore, we can conclude that Audrebian performed better in trigonometry. So, in order for you to uh, to to understand well, so where we're going, I'm going to 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 s- to the bell shape of these two, of the two score of other biens, the calculus and trigonometry. So as you can see in the screen, there are two bell shape. So the on the left side, it is the score of other biens in calculus. So ang interpretation ato is below the mean. So score Audrebian score in calculus below the mean. So mo na siya ang nasa left side. I-crash out na to na siya gikan sa mean to 1 unit below the mean sa negative 1, crash out mo na siya ang score ni Audrebian sa calculus. On the other hand, naapoy bell shape sa right side, which is a score of Audrebian in trigonometry. So Audrebian's score in trigonometry, 2 units above the mean. So as you can see, there are two sa 2 midpoint niya na ay 2 midpoint dira. So i-crush out na to mo na ang score ni Audrebian sa trigonometry. So there are two possible values of z-score. So positive z if the root score is above the mean, and negative z if the root score is below the mean. To avoid confusion between the negative and positive value, use the t-score to convert row score. So t-score is another type of standard score where the mean is 50 and the standard deviation is 10. In z-score, the mean is 0 and the standard deviation is 1. So to convert the root score to t-score, find first the z-score equivalent of the root score and use the formula t-score is equals to 10z plus 50. So also, t-score describe how far from the mean an observation is when the data follow a t-distribution. So to convert row score to t-score, find first the z-score equivalent of the row score and use the formula t-score. So t-score is equals to 10z plus 50. So in order for us to know the t-score, since we already solved the z-score, so in this case we were going to solve for the z-score. So on the left side here, the formula is t equals to 10z plus 50. So t-score equals to 10z plus 50. So sa first nga sa calculus, ang z equals to negative 1. So t-score equals to 10 minus times negative 1 plus 50. So 10 times negative 1 equals to negative 10 plus 50 equals to 40. So the t-score for the calculus is 40. On the other hand, t-score equals to 10 times 2 plus 50, which is ang 2 gikuha na to siya sa score ni Audrebian sa trigonometry. So i-times na to siya by 10 equals to 20. Plus 50 na to equals to 70. So ang score ni Audrebian sa trigonometry by using the t-score is 70. So interpretation or the analysis. So z-score of negative 1 is equivalent to a t-score of 40, and z-score of positive 2 is equivalent to a t-score of 70. The negative value is eliminated in the t-score equivalent. So therefore, Audrebian performed better in trigonometry than in calculus due to a higher value of t-score, which is equal to 70. So here, since there are two shapes as you can see in the screen. So with the mean of 50 sa t-score manggod, ang mean jud ana is 50. Di jud na pwede mag 60 ana. So the mean is always 50. So since ang nakuha ni Audrebian sa calculus by solving using the t-score formula is 40. So we can say that Audrebian's score 1 unit below the mean. So 40 mo na siya i-crush out nato. On the other hand, napud tay bell shape dira ang from the mean is above the mean, 2 units above the mean. So mo na score ni Audrebian sa calculus. So there are what is the two comparisons of the z-score and the t-score. So from first is standardization of data. It's standardization from population data, while the t-score it's standardization from sample data from the mean. So sa ato ang natanaw ganiha is an average is always 0 for the z-score, while an average is always 50 to z-score. Mo to siya ganiha. So ranges. So z-score ranges from -3 to +3, while t-score ranges from 20 and 80. So standard deviation. Standard deviation is always 1 for the z-score, while the t-score standard deviation is always 10. So sa result, by derived result from the z-score can be negative, while the t-score derived result can never be negative. Sorry. So distribution, the z-score is part of z distribution, while the t-score is part of t distribution. So with the increase in size, the z-score tends to be used, while the t-score with the increase in size, its useful reduces. So that is the z-score and the t-score, and that is the differentiate of the two score.